Hello friends, today's question. A piece of wood of mass 0.03 kg is dropped from the top of a 100-meter height building. At the same time, a bullet of mass 0.02 kg is fired vertically upward with a velocity of 100 meters per second from the ground. The bullet gets embedded in the wood. Then the maximum height to which the combined system reaches above the top of the building before falling below is, taking G as 10, so we have these four options and we are going to find out the height above the building before it comes back or falls towards the ground. So let us consider the first part, that is before the collision between the bullet and the wood. Before collision between bullet and wood. So in this case, suppose this is the building and its height is given as 100 meters. And we have wood of mass m1 and bullet of mass m2, and the mass you can say wood is dropped, so its initial velocity u1 will equal to 0, and the bullet is fired upward with the initial velocity, suppose that is u2, and that is given as 100 meters per second. Let us suppose this is the point or the level at which the collision takes place. So the distance traveled by the wooden block in the downward direction, let us suppose that is given as h1, and for the bullet this height is suppose is given as s2. So this is the point where they meet with each other, or bullets get embedded inside the wooden block. And from here figure we can clearly say that the height h1 plus s2 will be equal to 100 meters. We say that m1 is the mass of wood and m2 is the mass of bullet, u1 is the initial velocity of wood, u2 is the initial velocity of bullet, h1 is the height traveled by wood before collision, and h2 is the height traveled by the bullet before collision. So these are the few of the parameters. Now let us consider for the wood. You can see for wood we are going to use formula S is equal to ut plus half at square, and we know that S is h1, so we can say S is equal to h1, u is equal to u1, which is equal to 0, and A will be given as g. And T is the time during which the h1 distance is traveled. Therefore, we can say that our h1 is equal to 0 plus half gt square, or we can say h1 is equal to 1 by 2 gt square. Similarly, we can write for the bullet also. You can say for bullet, S is equal to ut plus half at square. Here the distance S is s2, u is equal to u2, which is given as 100, and A is equal to minus of g, and once again time, T is the time during which the distance s2 is traveled. So here we can write that s2 is equal to u2 excuse me please, minus half gt square. Now we already said that h1 plus s2 is equal to 100 meter. So let this equation number 1, and this we call as equation number 2. So we add equation 1 and 2. Adding equation 1 and 2, we get h1 plus s2 is equal to half gt square plus u2t minus half gt square, and here these two terms cancels out, so this comes equal to as u2t, and h1 plus h2 is 100, so we get 100 is equal to u2 is also given as 100 multiplied by t, so here we get t is equal to 1 second. Now we have that wooden piece with mass m1 is traveling downward, and we have a mass m2 which is moving upward, and suppose this is the point of collision. So m1 just before collision is having a velocity of v1, and m2 just before collision is having a velocity of v2, and the height we already said is given as h1 for m1 and h2 is for m2. So you can say for wood, speed just before collision is, so this is point of collision, point of collision. So we can say speed for wood just before collision is v1. For wood, speed just before collision is v1. So we can use the equation v is equal to u plus at. Here v is equal to v1, u is equal to u1, which will be equal to 0, and t we already know, and a is equal to g. So we get this as V1 is equal to G multiplied by T. G we know is 10 and T is given as 1 second. So this is 10 and T is equal to 1 second. Therefore, we substitute the value. This is equal to 10 multiplied by 1 and we get V1 is equal to 10 meter per second. So this is the velocity for wood just before collision. And similarly, we solve it for wood bullet now. So you can say for bullet, speed just before collision is V2. So once again, using the equation, V is equal to U plus AT. Now V is equal to V2 and U is equal to initial velocity, which is U2, which is given as 100, and A is equal to G, which is equal to 10, or we can say minus, and we have T is equal to 1 second. Therefore, we can write that V2 is equal to 100 minus 10 multiplied by 1, or we can say V2 is equal to 90 meter per second. So we got the velocity of the wood as well as bullet just before the collision. Now we already know that in case of the bullet, the distance traveled by the bullet is h2. Okay, just before collision we can say. So let me redraw here again. So we have our M2 and this is the point of collision, and this height is given as h2, where v2 is final velocity, which we got as 90, and u2 is its initial velocity, which is 100. So we can use the formula s is equal to ut plus half at square in order to find out the height h2 traveled by the bullet. Okay. We can say distance traveled by the bullet just before the collision. That is given as S2. So we can use the formula S equal to ut plus half at square, and we know that S is equal to S2, U is equal to U2, which is given as 100, A is equal to minus of G, which is equal to minus of 10, and T is equal to 1 second. So we substitute it here, we get H2 is equal to 100 multiplied by 1 minus 1 by 2, A is about 10, and this is equal to 1 square. Now we solve it and we get S2 is equal to 95 meters. Okay. Now we come to the second part, that is after collision. After collision between bullet and wood. we can say that just before collision, m1 is traveling downward with the velocity of v1 and m2 is traveling upward with the velocity of v2, and after collision they become one system, and let us suppose that is given as m1 plus m2, and combined they travel with the velocity of v. So you can say this is before collision and this is after collision. And we said that bullet and wood move together after collision with velocity v. Now we can use conservation of momentum. Conservation of momentum before collision and not after collision. So before we can say is our m1 v1 plus m2 v2 is equal to m1 plus m2 multiplied by v, and the direction of m1 is opposite to that of v2, so we put here a negative sign. So here is m1. So this is our before collision and this is the momentum after collision. Now we substitute the value. m1 is given as 0.03 and v1 we already know is our 10, plus m2 is given as 0.02 and v2 is 90. So this is 0.02 plus 0.03 multiplied by v. We can say this becomes 3 by 100 multiplied by 10 plus 2 by 100 multiplied by 90, and this will be 5 divided by 100 multiplied by v. So this 100 cancels throughout. We are left with minus of 30 plus 180 is equal to 5v, and this we can say is 150 is equal to 5v, or we can say the velocity of the system is 30 meter per second. So this is the combined velocity of m1 and m2. Next, we assume that the maximum height reached by the system of bullet as well as the wood is capital H. Okay. You can say maximum height reached by bullet plus wood system is given as H. So we can use the formula v square minus u square is equal to, so let me write this way, v square is equal to u square minus 2gh. From here we can find out that our h is equal to v square upon 2g. So we substitute the values. We get h is equal to, the velocity we already found out is 30, and 2 multiplied by 10. From here we get h is equal to 45 meters. This we can also represent by the figure. So this is the building whose height is given as 100 meter, and the point of collision between the bullet and the wood, or we can say distance traveled by the bullet, which is given as h2. So this is our h2, and we found out that h2 is equal to 95 meter, and this is for m2, that is for the bullet. And after collision, the height traveled by the combined system is given as by capital H, and which comes equal to as 45 meter. And we are supposed to find out the height above the building. So this is height of the building. Okay. So therefore we can say maximum height let me rephrase this one. Maximum height reached by the bullet and the system after the collision, that is given as h. It will be much more clear. And here is the maximum height reached by the bullet above the top of the building. Okay. So this is the top of the building, and we are supposed to find out this one. Let us call that as h max, given as h max. So we can say that h max will be equal to 95 plus 45 and minus 100. This comes equal to as 140 minus 100. So we get h max is equal to 40 meters. So this is the height, maximum height reached by the bullet plus wood above the top of the building. So we get h max is equal to 40 meter. Therefore we have option D is the correct option. You can say option D is correct. This completes the question. Thank you.